Hi, I'm Ryan Smith. I'm an associate professor in the Department of Entomology here at Iowa State University. And today I'm going to talk a little bit about some of the mosquito surveillance activities in which we run more or less in cooperation with the Iowa Department of Public Health and several local county public health partners located throughout the state. And so our program is really meant to understand mosquito populations and some of the dynamics, the numbers of mosquitoes, if they're infected with things like West Nile virus, and to better understand if new mosquito species are finding their way into the state and what potentially that means. And so with this data, we are kind of in constant communication with these public health partners and to really better understand how these mosquito populations and if they are infected with West Nile virus, how this kind of changes over the course of the season. So each of you might think of a mosquito as just being a mosquito. Well, I look at that a little bit differently. And all told, we found about 60 different mosquito species here in the state of Iowa. Most of you are probably more familiar with a couple. Some that you might interact with or unwantingly on a more regular basis, and one of which is Ades Vexans, and this is kind of our primary nuisance mosquito, and this is a mosquito that comes out in really large numbers after big rainfall events. And so more than likely those kind of mosquitoes that are out there biting you during the day as you are outdoors, this is Ades Vexans. But one important thing is that they don't really transmit any disease, so they are just a nuisance. They're out there annoying, kind of trying to swat away as you're trying to go fishing or camping or whatever that may be. The ones that we need to worry about a little bit more from a disease perspective are Culex species. So depending on the location in the state, some of the ecology of where we find these species can be very different. In the western part of the state, we have Culex tarsalis, which is our major vector of West Nile virus. And kind of in your more populated areas, we also have two other Culex species that can transmit West Nile virus, Culex pipiens and Culex restuans. And these are some of our kind of primary target Culex species as we run our mosquito surveillance. Another thing to have some concern about is the introduction of invasive mosquitoes that are not native to this area. And over about the last 15 years, we've recognized two different Ades species that have been introduced into the state. One, Ades japonicus, and then more recently, Ades albopictus, that have kind of brought in, most likely through tire trade or other kind of shipping, and have been able to establish themselves to some degree here in the state. And this is a little bit more of a concern because they are more aggressive human-biting mosquitoes and do have the potential to actually transmit disease if some of the arboviruses like dengue and Zika and chikungunya that we might not typically think of here in Iowa, these mosquitoes can at least have the potential to transmit. Any cases here in the state right now would be very rare and very unlikely that you would actually have transmission of these diseases, but we at least have these mosquitoes. And another concern that we have is climate change. And as the world gets warmer, that's important for our mosquito species as well, because it determines where you might see these mosquito species. Just even a couple degrees can mean a lot in the lifespan of one of these mosquitoes, where if they lay their eggs or depending on how they survive the winter as either eggs or adults, if you get freezing temperatures or not can really determine whether they survive and can kind of hatch out that next year. So the freezing points are really important, and so just a couple degrees can really determine on whether these mosquitoes can survive in certain locations. As the world becomes warmer, they can actually survive and thrive in more and more locations. And so we are seeing kind of the spread of these invasive species often into new areas. So that is also another main concern and one of the kind of aspects that we're trying to address with our mosquito surveillance. So this right here is kind of one of the kind of standard traps that we have here that we run throughout the state. This is what is referred to as a New Jersey light trap, or NJLT. And so this is used to get general estimates of mosquito populations, where as you can see there is a light. The mosquitoes are actually attracted by the light itself, and then once they fly in here, there is actually a fan that is pulling anything that kind of flies into this path downward. And so right in here is actually our collection tube, where we have a little kind of pest strip, more or less, to kill off any mosquitoes or other insects that could potentially get into the trap. And so every day, or maybe every couple days, either Iowa State personnel or some of our partners will come out and collect the tubes and collect the mosquitoes that are inside. And then these are sent to Iowa State, where we do the identification of all of the different mosquitoes that we do collect, and get a general idea of what kind of population trends are for mosquitoes in the state. And so we have a trap network, kind of at least right now, in 7 different counties. And so we've been able to kind of maintain or understand what these mosquito populations look like. And something that's unique to Iowa State is that we've been doing this type of surveillance for over 50 years. And so we have a vast collection of data where we have population estimates collected with this trap for decades. And with that, we can use information to understand how these mosquito populations kind of ebb and flow per year, how the dynamics of these populations are changing, maybe how some species kind of increase in number while others decrease. And so we can use all of this information kind of pooled together to really understand these mosquito population trends in the state. Really, the power is our real limitation as to where we want to put it. And even kind of depending on the location, even if we kind of, maybe if we moved it 10 feet this way or 10 feet that way, we would see a big difference in the mosquito populations as well. So the trap placements are also really important here. And it's better to get a little into kind of the tree line itself and have that protection and shade. Mosquitoes, they do rest, and so they spend a lot of their time actually in resting areas, kind of on trees or other kind of vegetation, such that they're not always out flying around. Okay, so right here, this is what we call a Gravid Trap, and this is part of our trap network that we use to sample mosquitoes for things like West Nile virus here in the state. And so a few different properties with this trap is if it's more or less a bucket, just to kind of mimic a potential breeding site. There is kind of what we refer to as stink water inside. And so this is usually some organics, maybe some leaf litter that's in there with the water, kind of creating a stench, frankly, that the mosquitoes are attracted to lay their eggs, such that they recognize this as being more or less a good habitat to lay their eggs. And so when they come in and try to lay their eggs in the water, some of them will actually kind of get caught underneath this little kind of platform and actually get sucked up into this container, where again we have a fan that is actually drawing the air upwards. So if a mosquito comes in, it's going to get sucked up into this collection container, in which every day or two personnel will come out and more or less change these containers right here. And so from that, we take the mosquitoes that we collect, and this also targets mosquitoes that have likely fed before. So this is a Gravid Trap, meaning that this is kind of looking for those mosquitoes that are wanting to lay eggs, meaning that they've actually fed on a person or a bird or another animal in which they're looking to lay their eggs. And so that means that they've also potentially been in contact with a host that potentially had West Nile virus. And so from that, we can take our mosquitoes, we can speciate what these mosquitoes are. Those that are Culex species, which are the primary vectors of West Nile here in the state, we send off to the state hygienic lab for actual West Nile virus testing. So they are really the ones that do all sorts of pathogen testing in the state, most notably COVID right now, but they're also continue to examine to see if our mosquito samples have West Nile virus. And so after a couple days, once we get the testing information back, we kind of input that and take a look at trends that we're seeing and the types of mosquitoes that are being positive, different species. And from that, we can kind of monitor what the season looks like. So right now, we actually are seeing a great deal of West Nile virus activity. in our mosquito populations, and from that information we can actually relay messaging to local public health departments and the Iowa Department of Public Health to go ahead and convey that messaging further. So we're kind of the middleman in the operation and the ones that are actually really kind of creating the pulse of what transmission looks like. West Nile virus is endemic to Iowa, meaning that we have transmission of the virus every year. Each year will be somewhat different depending on the environmental factors, the mosquito populations, the bird populations, all sorts of variables. And we've been looking at this for enough years that we're starting to understand some of these trends. We don't know everything, but monitoring our mosquito populations using this trap is a big part of that. If potentially they're sitting on that water surface and get sucked up under this trap, this is a collection tube with a fan up here on the top. That will then kind of pull those mosquitoes up into a collection chamber. And so this is really built on the oviposition aspects of the trap itself and really selecting for certain mosquito species. There's a 12-volt battery in which we can kind of just transport these traps and put them more or less anywhere as long as we have battery power. So each time someone is coming out to check on the trap, they're going to replace the battery with a fresh one. Such that when they're collecting the mosquitoes, they're also going to change out to make sure that the fan has enough power to run for the next couple days. An important aspect too is that with this trap, this is again an oviposition trap, such that the females are the ones that are laying the eggs. The female mosquitoes are the ones that are actually taking the blood meal. The male mosquitoes don't actually blood feed. So again, this is going to select for your female mosquitoes, the ones that are blood feeding, the ones that are likely coming into contact with any virus. We're also using a relatively new trap here in Iowa, right here, which is a Gravid Ades trap. And so this looks pretty much like a simple bucket. Well, it is, but it's been designed selectively based on these colors, both the black bucket and then again kind of this lid that really select for mosquito species that like to lay in containers. Usually those are kind of found in and around the home. And so using just a little bit of water, these mosquitoes can lay their eggs and breed. And so with this trap, we're actually selecting for Ades mosquitoes. So this is different from the other Gravid traps that we've shown that are really selecting for Culex. More recently, we've actually seen the introduction of an invasive Ades species into the state, Ades albopictus. And so we've actually, for the last few years, we've been monitoring this kind of since 2016, when the Zika virus scare kind of came into the United States. And we really didn't have a very good understanding of what these mosquito populations looked like. And so we've spent significant efforts going through probably at least 30 counties all told in the state, in which we have put out traps just like this to really select and see if we can't catch some of these Ades mosquitoes. Using traps like this and others that really select for these Ades populations, we've now kind of more or less demonstrated that these populations are established in 3 counties and actually seem to kind of continue to spread. And so this is an important aspect of the trap right here, where we actually have a kind of sticky card which can easily be replaced. And this one is obviously blank, but if a mosquito flies in, it can't really get out and can potentially come in contact with this sticky card and is caught there. And after usually about a week, we can come back to this trap and kind of find any mosquitoes that could be on here. And with that, we can then identify the mosquitoes, and if they are Ades albopictus, we've also been collecting them and actually sequencing some of their DNA to see where they've even come from. And what we found is that we are getting introductions of these populations coming from nearby in Illinois, and we're also seeing the spread of these mosquito populations that were likely introduced into Texas and have kind of spread kind of throughout the United States. So this is a newer introduction of a trap into our surveillance, but it's also really been a useful tool. It's really cheap and it works really well. And so using this information, we can really assess if there is a severe risk, or what risks there are for human populations from mosquitoes. The majority of time, these mosquitoes are really just a nuisance, an annoyance, as they kind of bite us during our outdoor activities. But as we kind of get into the later summer, we need to start worrying a little bit more about West Nile, which is going to be found pretty much every year here in the state, even though the activity levels can really differ between each season. And so in addition to these kind of questions, we also, from the health perspective, we're also interested in providing information for kind of local mosquito control partners to more efficiently spray and kind of more knowingly know when the peak times of mosquito activity are. And so partnering with these other researchers, we can actually take in the information that we're getting from our mosquito surveillance and convey, hey, you've got a lot of mosquitoes this time, I would recommend that you spray in a certain location. And so using this information, they all kind of have their own little thresholds for mosquito activity, but typically our partners will kind of set a general threshold of activity and the number of mosquitoes in one of our traps that they might find in a week, and use that information to go now out into the field and kind of spray with a better understanding, instead of just constantly spraying with pesticides that can also have kind of downstream side effects. And so we're using this to control our mosquito populations with a little bit more kind of intelligence and knowledge to avoid things like insecticide resistance.
Anything?
There's maybe one that I'm not going to share for the camera.